Page 94, numbers 1 and 3. We are to determine whether the formula determines y as a function of x. If not, explain why not. So with number 1, we are given the function y equals the square root of x minus 4. And this is indeed a function. We could look at the graph, and what we could see is that when we go under y equals, let me turn my plot off. I can put the function in. Oops. X minus 4. And what I see is that even if I change my x max value to like 50, count by 2's, I'm going to see that this will pass the vertical line test. Each x has a unique y, which is what I want. So this is indeed a function. Now when I look at number 3, what I can see is that it is not solved for y, and I need it to be in terms of y for it to be a function. So let me solve it for y. So dividing both sides by 2, I have x over 2 equals y squared. Now I have to take the square root of both sides. And when I do that, I get that y is going to equal plus or minus the square root of x over 2. So I have a little problem here because I have two different equations to determine y. So y could be the square root of x over 2, or y could be negative the square root of x over 2. So putting the same x in either equation is going to give me two different values. So this is not a function, and my reasoning is going to be each x has two distinct y values, which is not allowed. It has to have one y value. So I have my original function. My original equation was a function, and my second one, number 3, is not a function.